Here we've got the dreaded ladder question from A-level mechanics. So let's have a look at this. So the start of these questions, you always want to do the same thing. Draw all your forces on the diagram. Okay, so first things first, reaction forces. Anywhere your plank is leaning on a surface or on any kind of object, you need a reaction force. So we're going to have a reaction at A, going straight up, and we're going to have a reaction at C, because it's resting on C and it's resting on the floor. Then check to see if you need any friction here. So we're looking for the word rough. So the ladder is on a rough ground. The ladder rests against a smooth rail. So there's no friction here, but there is friction here. And the ladder is trying to fall down, right? It's trying to slip like this. So that means friction is going to act against it. So we're going to have friction going like this. And then, of course, we need the weight of the plank. So let's see what they said. The masses. The ladder just has mass M. Okay, we've got a very kind of all letters, these kind of questions. So we're going to draw an arrow down and say the weight is M times G. Do we need any other forces? Let's skim through and see if there's anything kind of strange going on here. Ladder rests against fixed smooth rail. The point C is at a vertical height. Nothing else has been said. So that's all our forces drawn on. And there's only, when it comes to the methods for these questions, there's only two methods. It's either going to be moments about a point or resolving the forces left and right, up and down. So looking at part A, we can see they're saying the magnitude of the force exerted on the ladder by the rail at C. So we need to find RC and show that's 9 mg. So because you can see it's a 3-mark question, they're just asking for one of the forces. Actually, the easiest thing to do here is just to take the moments about A. Okay, so the reason we're doing that is because if we take moments about a point, we can ignore the forces at that point. So we're going to get rid of RA, get rid of FR, and we'll just get an equation involving RC and MG, which is exactly what we want. So we need to get the moments of these two forces. So that means anything that's not perpendicular, we need to resolve. I'm looking at this MG, this is not perpendicular. So we need to turn this into a triangle. Yeah, that's right angled. Move your angle into the triangle, so that's going to be here. And then resolve just with your friendly SOHCAHTOA. So we have MG is the hypotenuse. This is adjacent to the angles. This is going to be MG cos alpha. And this is opposite, so it's going to be MG sine alpha. Ideally, yeah, you just match up. Okay, this is adjacent, so it's cos. This is opposite, so it's sine. But you can always kind of write out the triangle, do your whole sine of alpha is opposite over hypotenuse if you're kind of confused about that. So now that's that part done. We've got all our forces perpendicular to the plank. So we're going to go ahead and do our moments. So remember, moments are force times distance. So force to the center of the plank is, distance to the center of the plank is 3a. So this moment is going to have the distance times by the force, which is mg cos alpha. Okay, that's going clockwise. So now we need to look at our other moment, which is anti-clockwise. So we need the moment for RC. Wait a second, we don't know the distance here because we only know the distance from A to B. So we still need to find the distance from A to C. This would probably catch a lot of people out, but the trick here is they've given you one side of this triangle. So they told us this is 4A. Let's draw this out. This is C at the top. They've said the height's 4A. We have our angle alpha here. And we know what sine alpha is. Sine alpha is 4 over 5. So that means sine alpha in this triangle is 4a over x, but we know sine alpha is 4 over 5, so we're going to plug that in. And you might be able to tell from this straight away, okay, they've just multiplied the top by a, so the bottom is going to be 5a, which gives our distance from A to C is 5a. So when we go into our moment, we've got our original moment, and then our second moment from RC is going to be the force RC times by the distance, which is 5a. Now looking at this, we have a cos alpha. So we have sine alpha here. Let's do our trick to find sine and cos, and occasionally the rare tan, but that probably isn't going to come up. So if we draw out a triangle, we're going to plug in alpha, and we're going to say, okay, so if the opposite's 4, the hypotenuse is 5, right? Because sine alpha is opposite over hypotenuse. Then doing a little Pythagoras here, we'll find this side, which will give us that this is 3. So then we can see from this, okay, cos alpha is adjacent over hypotenuse, which is 3/5, and we already know sin alpha is 4/5. And let's put tan there for safekeeping. Opposite over hypotenuse, which is 4/3. So now looking at our equation, we can simplify this because we know cos alpha. So we're going to say 3a times mg times 3/5 is 5ARC, just kind of organizing that a little bit. Simplify anything you can cancel from both sides, so we're going to cancel the a's. Simplifying this, we have 9/5 mg is 5RC. RC is 9/25 of mg, which is exactly the answer we're looking for. Okay, on to part B, hence or otherwise find the value of mu. So bearing in mind we've done the moments here, it's probably going to involve, for part B, it's probably going to involve resolving the forces, left and right, up and down. So let's do that now. We'll just get our two equations here. R up is, okay, again with this is diagonal now, and we're looking up and down, so we need to resolve this. Put your angle in. Your angle alpha would be here, meaning this would be 19 minus alpha. So this is going to be alpha over here. You always need to kind of figure out where your angle is inside that new triangle. So we're going to put a right angle here. That means this will be RC cos alpha, and this will be RC sine alpha. So when we're doing our up forces, we've got this going up, this going to the left. So that means that RC cos alpha plus another upwards force is RA is equal to our downwards forces, which is just mg. That's the only force that. Let's simplify here because we know RC and we know cos alpha, so let's plug them in. 9/25 mg times by 3/5. RA we don't know. Okay, equals mg. I'm losing my voice here. I've been talking all day. So we're going to do 9 times 3, so 27 over 125 mg plus RA equals mg. And then we might as well solve here for RA. That's going to be 125 minus 27, 98 over 125 mg. And that's not what we need because we're looking for mu, but this is just going to come in handy later when we do our friction equals mu r part of the question. So now let's go on ahead and do the only other thing we haven't done, which is resolving left and right. When we look at the diagram, we can see the forces, friction to the right, and RC sine alpha to the left. Those are the only two forces. So friction equals RC sine alpha. So yeah, to the left we have friction equals RC sine alpha. And then again, simplifying. So we have RC is 9/25 mg and sine alpha is 4/5 times 4/5. Simplify 36 over 125 mg is friction. Let's underline both things we learned from doing these equations. And now looking at what we're actually trying to find in this question, find the value of mu. So we have friction and we have RA. We know our formula is friction is mu r. Assuming we're in limiting equilibrium, remember it can be less than or equal to this. If it's in limiting equilibrium, friction is mu r. So we can see here, limiting equilibrium, that's fine. So friction, which we've worked out, is 36 over 125 mg, is mu, the end goal, times r, RA in this case, which is 98 over 125 mg. Cancel early just to make your life easier. So cancel here. And then, cancel again. We can get rid of this. Divide 36 over 98. And then simplify if possible. 18 if my mental maths is correct. And that's your answer. Okay, I hope that helps. Just remember there, you've only got those three methods. You've got moments, resolve left and right, resolve up and down. And putting all those equations together, you should be able to battle your way to the answer.